Hello, Marvin. This is my demo video for my Ekonify MLOP. The platform I worked on is an AI platform that classifies images with built-in functionality to retrain, and also there's a visualization page that makes the user understand the data that was used to train the model. For the predict, all the user needs to do is just upload a picture of a particular waste type, and it's going to predict the kind of waste it is. And this is to help with waste optimization, looking at where I'm coming from, Lagos, Nigeria, that is very dirty. So once they upload, it's going to tell them, and it's going to tell them how to recycle it. So if you know that this is plastic, you are going to know how to recycle the plastic, right? The technologies I use Python, I use Fast API, I use MongoDB for the database. I use Render to deploy the front end. I use Railway to deploy the back end. So this is the deployed website right here. And I'm just going to reload real quick. So now that I've reloaded, this numbers are counting, which means my JS files are working well, my JavaScript files. If you click on start classifying, it takes them to the predict page. If I click on the logo, it takes them back to the home page. If I click on view impact, it takes them to the visualization page right here. So this is visualization of the data that I used to train the model. We could see that there was class imbalance, and then I used oversampling to make it balanced. This is the pixel intensity distribution. This is the training and validation performance, and also the image dimension analysis. If you go right here to retrain, there are three options which I'm going to be explaining later on. I had issue with uploading my backend to Railway because of to render, because it's too big. It's bigger than the free version that we're given. But I'm still trying Railway. But I'm making this video just before then. So I'm going to go to my VS Code right now, and I'm going to, you can see here the API I started running. On my second terminal, I have my front end on the local host, so I cannot run it on the REM deployed front end because I'm having issues with uploading the database, but I'll still continue working on it. So for the code, this is the home page right here. Then for my notebook, so I have my notebook right here. And just to show us how I retrained, so I used the model that I previously trained in my intro to ML, which this is it. I did not delete it. Where I started retraining for the MLOps. So I'm using the baseline CNN because that was the best performing model in my intro to ML course. And that's what I'm using retraining now to do this MLOps. So this was where I started the MLOps. I pre-processed it. Like I mentioned earlier, I said there was oversampling. I mean, there was class imbalance in the work. So this is the class imbalance that happened. And then I pre-processed it using I copied the data set first so that in case it gets corrupted, I can always have it back. Then I oversampled everything to the highest number of the highest class in the previous class imbalance that we saw. And then I divided my data into I use generator, string generator, validation generator, test generator. I also separated the data set into train, val, and test data, which really helped. And this was where I loaded my best performing model. Right here, this is the model architecture. In the intro to ML, I did not use any hyperparameter. We used nothing. We just trained it like that. So for this one, I added hyperparameters. I added dropout layers. I used max pooling as well. I used global average pooling instead of flatten because I was having issues with flatten. In the intro to ML, I use flatten instead, but yeah, I'm using global average pooling. And my optimizer that I use Adam W optimizer, and this is the model architecture right here. And I trained it for 20 epochs, and if you can check here, the model automatically saves with the highest validation accuracy. And these are just more prediction, confusion matrix, checking the precision F1 recall and all. And then I saved the model. So right now we're going to run this to see how it is working. So this is my Mongo base here. If you check it, I've connected it, and if you can see, there's just admin, config, and local. So we're going to now see if what I'm going to do is going to work. So we're going to come back to this. So now, just quickly, this is it here running already on the local host. Let me just reload. Yes. So right now we're going to, once the user comes, the user moves to predict tab, and you just click on browse, then you open your, so I'm just gonna go, start from test underscore data, and let's try to predict cardboard. So I pick this cardboard right here. Once I pick it, it shows here the image that was selected shows, and I click on predict. And you can see here the results came out: prediction, cardboard, confidence, 76.99% confidence. So if you want to predict something else, you click here again. So I'm gonna go back to, so I'm using images from the test data. So I downloaded the test data, like I mentioned earlier, that I divided it into test data, val data, and train data. So now I'm taking from the test data to, of course, like test it. So now we're going to be trying biological. So I'm going to just randomly pick one image there, and we're going to click on predict. You see, it's predicted before, it was cardboard, it predicted, but now it has predicted biological, and the confidence is 98.42%. So before I move on to retrain, let's go to our database and let's see if it works. So I'm going to come right here and click on reload data, so that it's going to reload. If you check here, the name of my app is Ekonify. That is Lagos, and making it clean. So if you click on Ekonify right here, we're going to see that image folder has been created. If you click on the image folder, remember the first prediction that was done was cardboard. This is it here. The file I uploaded was cardboard, and it predicted cardboard. The second one that I uploaded was biological, and it's predicted biological, which means that the database has been integrated with the API and everything is working well. So now we'll move on to retrain. So the way this retrain works, right? I mentioned earlier that I use the model for my intro to ML, right? So the model is called baseline CNN, and if you check a retrained baseline model, so the retrained one that I trained, I had more higher val accuracy. So we have just those two models in here, but I'm going to be using the baseline CNN. So these are just the upload requirements that tells the user what to do. So we have where they upload data sets, and then the data sets that they upload is what we're going to use to is going to save to the backend. So when user uploads new data set, it will save to the database, and then when they come to continue training here, it's going to use the model that was trained from here. So once they click here, they train the model, the retrained model result that was gotten will be saved to the database. Then when they come to continue training, instead of them to upload, they don't need to upload, is going to use the retrained model that has been saved to the database. Then they can always pick any data set that they feel like using, and then they can use it to retrain the model. If you see here, it says no data set found in the database because we are yet to upload anything. So now we've picked baseline CNN right here. So now we're gonna drop a zip file. So I'll go to my downloads. If you see here, I downloaded everything: over sample, train, test, val. So for this one, we're going to be using test data, and it has to be a zip file. So you can see it dictates that yes, that the zip file has been uploaded. So now I'm just going to click on start training. So it takes us through the processing data sets, uploading to the server. And now it has started training the model. So as this progress bar is going on, I'm gonna take us through to my VS Code, where we're going to see it. So this is the API terminal right here. So as you can see, when I clicked on to retrain, when I clicked on to predict, you can see here that the predicting worked. And right here, when I clicked on to retrain, right, you see here it looked for the model with baseline CNN. So it looked for the model, it told us the available models, then it found the model, loaded the model, checked for the input size of the model where the retraining happens, tells us how many files it found, because I'm working with 12 classes for my classification model. So now it has started training. So I'm just gonna do 1 to 3 epochs. I'm just doing 3 epochs. So it's already training right now. If we go back to my front end, you see it's right here, that training model. All right, so now the training has completed, and this is the training result. This is the terminal right here. So if you check here, it says database, model stored in database. So it stores the model and it also stores the data set that was used to train. I uploaded test data set to train the model. So it saves the trained model and it also saves the data set. So now going back to my MongoDB dashboard, I'm going to click on view, then I reload the data. Upon reloading, you can see this option here, this folder here that says models. So we trained baseline CNN, right? And now it has shown us like the retrained baseline CNN. If you also check the data set that was uploaded has also been saved, which means that it is working. Click on continue training. So here I select the model. I'm going to select baseline CNN. And here you see, as I clicked on baseline CNN, it brought out the results of the last trained model. It said it was trained, brought out the previous epoch. Then right now, I'm going to pick the number of epoch that I want to use. So if I click on one epoch and I click on continue training, it's going to take us through that process as well. Going back to my terminal, I clicked retrain, right? So it retrieved the latest retrain model. Remember the one that was trained, that was into the database. It retrieves it, it loads it prepares it to start training. And remember that I clicked on one epoch, that I want one epoch. So now it's just training for one epoch. If you select 2, 3, 4, 5 epochs, it's going to train for the number of epochs that you picked. So now we're just going to wait for this to load, finish. So here the training result has been completed. So it gives us that 4 epochs, because remember, we're continuing from the model that was trained before. So the model that was trained before was trained with 3 epochs. So 3 plus 1 epoch that I selected, that's everything, makes it 4 epochs. Go back to my terminal, you can see that it's only trained for 1 epoch. And if I go to my MongoDB, I just come here, click on view. I always have to reload this data. So if you go back to the models, you see that we have now 2 models, right? This one was retrained. This one is now retrained extended. The next one, use existing data set. So here I'm just going to click on the same model that we've been training, and I'm going to click on, let's say, 3 epochs, and I click on start retraining. So for this one, it's going to pick the existing data set that we have. Remember, we uploaded test data sets in this first place here. So it's going to go and take that. In this continuing training, we did not use any of those data sets that is there. We only continue training from the model that we've trained already. But this one is now going to use the test data set that was there. So now I'm going to click on start retraining. So now it's done retraining and it also returns the result. If we go back here as well, we can see, so it trained for 1 epoch because that is what I told you to do. So if we go to retrain.py here, we're just going to, if we go down here, I set the default retrain to be 1 epoch, which is the reason why it trained as 1 epoch, which saves us time. So now we're just going to click on train another model. So if you click on train another model, it takes you back to say pick a model, and then you can start retraining. So as I explained earlier about this, the model accuracy is at least 75%, as we've seen in the retraining results and also in the predict result and the total predictions that has been made. So yeah, that's for that. And going back to my code, this is the front end, this is the API right here, and this is the database code here as well. These are the models. So as much as the models save to the MongoDB database, it also saves locally. See the amount of models that I have trained, right? The retrained one. These are the ones that I uploaded that you are seeing the two options. But now that we've retrained, these are the results, right? Saved in Pico file. Come here and click on reload data. You see that another model has been added to it again, which means that everything is integrated and is working. And it took me a lot of time to be able to figure out, because I was having issues with the front end show, with the training reflecting on the front end, but I was able to do that. Also, I had issues with the model and with the metrics, and yeah, it's been a journey. Thank you so much.